All right, we're going to get going and do some introductions here. All right, we've got, so this whole thing this today was innovations, and so there are some innovations coming in microsurfacing, and I love our customers because, I don't know about you guys, you go to somebody and says, yeah, we want to try that new stuff called microsurfacing, and it's like, you realize that's been around about 55 years, don't you? And but it's still new. It's still new. So we're talking about innovations with Wrap Micro, Wrap Cape Seal, and Fiberized Micro. So first we've got, and Paris, is it Navarro? Paris Navarro, spent 29 years with the Kentucky Transportation Cabinet, with the last decade focused on pavement preservation, a passion that led her straight to Strauser Construction. She's all about keeping roads smooth, safe, and sustainable. I don't just talk pavement, I live it, and I believe that. She's a proud mom of 2 grown sons, married to her best friend for 16 years, loves road trips, especially when it's pavement preservation perfect, known for turning any pavement chat into talking about pavement preservation, and believes preservation is the key to smarter infrastructure. Amen. And then she's going to go for about half of this, and then Mike Metzer has been in the industry for almost 25 years. He started working for a QA/QC firm while attending college at night. Upon graduating with a construction management degree, he worked for 14 years for the Delaware County Engineers Office, one of the top 15 fastest growing counties in the nation. The last 7 years at Delaware County, he designed, managed, and ran over $100 million of road construction work. 6 years ago, he joined the Strauser Construction family and has helped governments better understand and implement pavement preservation in 6 states and counting. So Mike will be up in a moment. All right, Paris, come on up.
I'd like to thank everybody for giving me the opportunity to come in and talk about some of the pavement preservation and talking about wrap microsurfacing, talking about Cape Seals. So I do think that this is new to the industry, and I think we need to start looking at sustainability and looking at ways that we can utilize wrap and pavement preservation and stretching those limits with wrap. So anyway, what is wrap microsurfacing and why is it becoming more popular? It's utilizing reclaimed asphalt pavement and our microsurfacing over the virgin aggregates. So over time, our virgin aggregates sources are going to start being depleted. But what's happening with our wrap piles throughout our states? Every state, the wrap piles are growing and growing. So let's start looking at how we can use this wrap into our pavement preservation techniques. So is all wrap the same? Raise your hand if you think all wrap is the same. Wrap is just like the mixed designs, right? We have different gradations. We have different high quality, low quality aggregates within our mixed designs, right? So that is the same way that all the wrap is. But what happens, we're not doing wrap management at this point, so we have to be careful. We need to look at all the different sources that we got, and we have to treat them basically as a low quality aggregate right now. So we also know that it can manage anywhere. The fines are going to have the higher AC content. The larger particles that you use for chip seals are going to have the lower lower AC content within those piles. So you also can check your wrap to make sure if it's polish resistant aggregate. I'm going to get into some of the deep dive that I was doing when I was with KYTC. So I'm going to go back and forth because I work directly with Strauser Construction when I worked with the Kentucky Department of Transportation. So they did a lot of the research with us when we was working with our wrap projects. So how do we process wrap? So there's 2 different ways you can do it. You can start out with screening wrap only, just doing a straight screening. You're going to process more, but you're going to have more oversized aggregates. You're going to have a waste of anywhere between 10 to 15%, maybe even more, just depending if you've got saw cut type, like base failure, blowout type material in your wrap piles. So just doing the screening is going to give you your chip seal aggregate and then your fines. And then your oversize is going to be kicked off. You're going to process more, but at the end you're going to have less material to work with because it's kicking your oversize off. So you can also go to crushing and screening that material. So when you're crushing and screening, what's happening is you're screening it first. All that oversize is going into the crusher. So then it'll fall through the screens and the appropriate screens, and if it is still oversized, it'll go back to the crusher until you can utilize 100% of that material. So when you're utilizing 100% of that material, you're going to end up with about 60 to 65% will be your fines. 35 to 40% is going to be your chip seal aggregate. So that just tells you what you're going to end up with. And this just shows you the different types of screens, or the different types of crushers you can use, and the screen sizes. So if you're looking at this might be something you might want to look at, because I'm going to tell you, when I was working with the DOT and we first started working with RAP, I thought, no problem. The processing is going to be 100% the easiest part of processing. Well, let me tell you, that was the hardest part, because we had a company come in that had actually been crushing rock. I'm going to tell you it's a totally different process, and I'll dive a little bit deeper into that about some collaboration and what we did with that. So you want to make sure, if you're an agency and you're wanting to use RAP and you're having a company do it, make sure it's a company that knows how to process RAP, or you're going to face some really big challenges. I mean, I did so many degradations, it just wore me out. So just, that's something to be mindful of. So this is kind of where 100% RAP and the challenges that come with using 100% RAP versus blends. With 100% RAP, you're going to have some complications that come with that. Using 100% RAP, you're going to have material that wants to compact inside the beds of your trucks. So without making modifications to that equipment, you're going to have shakers or vibrators within those beds to make sure agglomeration doesn't happen. And you're able to get that material out into your microsurfacing machine. So it also, you can end up with buildup. You get buildup in the spreader box and the pug meal. You can get more drags and buildup on the rubbers a little more frequently. So therefore, it's going to require a little more maintenance. So I think it becomes more challenging. Once again, you have to be a little more careful for wheel rutting. If you've got wheel rutting, you can have some problems with this material. You can end up with more surface damage. I've seen projects maybe that's been 100%, and then maybe they're tender a little bit longer, right? Because you're using 100%. So with a 50-50 blend, you eliminate a lot of those problems. So you'll use 50% of your RAP with 50% of virgin aggregate. So you get rid of the compaction problem. You don't need no additional modifications to your equipment, because it will not agglomerate like it would if you was using 100% RAP. You minimize your material buildup. You can use multiple layers. So a lot of people that I've seen that's doing 100% RAP, they're doing it in a single course. They're doing thinner lifts. So you can up your poundage, you can do it in multiple layers, and you don't have those high temperature issues when you're using this material. So I really do like using the 50-50 blend. I really think, especially working in Kentucky and us doing the RAP, trying to save dollars, and there's some other stuff I'll get into, diving a little bit deeper into using RAP, is that the industry challenges that Kentucky faces. So I have to be very careful and vigilant about what I'm doing, or what I was doing. So you heard Andy talk about his collaboration with Kentucky. Kentucky also collaborated back with PennDOT. So it was really interesting. I was thinking, we got to collaborate to figure out how to get this done. That's how we get there. So when I started looking at it, the reason I was looking at it from a state standpoint was, if we do chip seals, we can spend $120 a ton for a washed aid, right? So I was like, we got to do something. So I started looking at RAP, and I knew that Pennsylvania had done RAP chip seals for quite a while. So I spoke to Dave Kaiser at the time, worked for Strauser. I was working for Kentucky DOT. He said, you really need to talk to Andy. So I talked to Andy, and we kind of shared stories back and forth. I came up to Pennsylvania, spent a week here, learned a lot, went around and seen projects, looked at things. We shared a lot of information, some stuff that a lot of agencies really don't want to share with each other. Sometimes if they have a failure, they hold their cards close to their chest, right? They don't want to share those lessons learned. Our relationship became an open book to each other, to share specifications, share lessons learned, share those things that we need to know to get from point A to point B a little bit faster and a little bit better. So this is just what I started with, the 4 bullet points. I did research, study, collaboration, and implementation. That was my goal. That's what I started out with. So when I actually looked at New Mexico, I was just looking at New Mexico more for how they were setting up their projects. I was looking at Pennsylvania because they were more like our climate condition. They have a little bit harder freeze cycle than Kentucky, but they were closer to our conditions. So I was looking at them for that. So right here is where Andy and Steve Young come down to Kentucky. They worked with our chip seal crew because talk about budgets. So I said, hey, I want to get some money to start chip seal in-house. And they said, well, it's got to be innovative. I said, okay, we're going to chip seal with wrap. They said, you're going to take a crew that has never chip sealed before in their life, and you're going to start with wrap. I said, absolutely, that's how I'm going to get money, right? That's right. I said, okay, we're going to do it. So after working with Andy, having Atnire come in and do the training, Andy and Steve came down to Kentucky. They helped the guys to understand the challenges with using wrap and chip seals. So then they actually helped with calibration. We shared a lot of information. And I wanted to thank Andy. I know he's not here now. I wanted to thank Steve, and I also wanted to thank Pennsylvania DOT for allowing this collaboration to even happen. I think that's more of what we need in industry and agencies sharing and collaborating together so that we can grow this industry better and stronger in the future. So when I was in Pennsylvania, what I did was I took a sample of their chip aggregate from where they had their wrap process and their microsurfacing aggregate. I took it back to Kentucky. And he's like, well, what are you doing that for? I said, I need a baseline, right? I need to be able to know the material. So I wanted to check the fines that they have in wrap, because I have found in wrap with chip seal, you can go up to 4% fines and not have a problem. But I also wanted to look at the microsurfacing sand to see if it met our gradations, look at the extraction to see what the AC content was of that material. So this is just some of the testing that was done on their material, and then when we processed our wrap, we did the same materials. So this information was split between these agencies. The test that we did on their material was shared with them, then the materials that we did on our own was shared back with them. Now when we did process or check the gradation of the fine aggregate for microsurfacing in the wrap, it fell out of spec in one of the sieves. But when we blended a 50-50 blend, we was inside the spec for gradation on that. So this is the first project that was done on the double-A highway. It had about 3,400 ATT on this particular route. So the picture to the far right would be day one of when they were done. These were both done. So we always had a control section. This was a double microsurfacing. We had 18 pounds on the bottom course with a type 3 aggregate. The surface course was a type 2, and half of the job was split. So we had a control section that was standard micro, and the last 2 miles was the wrap. So we wanted to be able to compare friction values, wear, all kinds of things. So it was a control section. This was a year later, and as you can see, it almost looks like a pavement joint. So more aesthetically pleasing to the eye, a lot better for visibility of your striping, so the appearance is really good. This was just taken a couple months ago. So we're at year 2 at this point on the project. Interesting thing about this was I also wanted to look at friction values, because I figured the friction values could be a little bit lower, right? Because we're using a wrap. So with the first year that we'd done this project, probably about 3 months afterwards, we ran a lock wheel. So with doing a lock wheel test of friction values, we had about 9 points difference on the first year. The second year that we ran it, or year 1, this wouldn't be second year, this would be a year later, we was only 2 points difference, which was impressive to me. It's like only 2 points difference between the wrap and the standard. So it's showing that it's performing very well. One of the questions that I've had about it is, do you see more cracking because you're using wrap? No. The cracking is the same between the wrap and the standard micro. So I'm not seeing a big difference. So they're continuing to monitor this. They have ran it, but the numbers have not been turned out yet. So at this point, because I don't work for the agency, they're going to give me those numbers verbally. They'll never send them in to me in an email, obviously. And once again, this is a taboo information that me and Andy shared. We shared our friction values. We shared this information. So I wanted to take it another step further. So we all know that RAP management really isn't a big thing right now. There's a push for trying to create RAP management. So I want to stretch the limits. I want to check and see what we can do. We had a district within the state that had RAP that had come off of an interstate. So it was polish resistant aggregate, so it's a higher quality aggregate. So what I wanted to do was to see if we could open up new faces to this aggregate and gain friction values back. Because one of the fun facts about Kentucky, they do not have polish resistant aggregate in the state. So all of it has to be hauled in and trucked in. So therefore, if I can open new faces and I can gain those values back, then maybe we only have to bring in 50% virgin, high-quality aggregate into the state and be able to process our RAP and be able to utilize that in and save dollars. The other process of doing this was I wanted to see if I could put the RAP on the bottom course. Because if I don't gain those friction values back, if I do have something that requires a polish-resistant aggregate, I can always use that RAP on the bottom course, which is still saving us dollars, right? So we put it on the bottom, and I saw the first project we did, I noticed that it wants to tend to hold water, right? So there's a lot of water that wants to come out of this material, so you've got to extract that because I didn't want to trap water or end up possibly floating emulsion by having too much water still in this material. So I had decided when we set this is before I left KYTC and went to work for Strasser, I had wrote the specs for this. And we added the pneumatic roller to help push that water out of that mat across the entire width of that roadway. So that allowed us to be able to the next day go over top of that. Now, once again, this was RAP on the leveling course. Then we went to the surface course. Then we split the project in half again. Standard micro for part of the project, RAP micro on the other half of the project. This is to be able to determine what the values are. This is the same ADT level as the road that had been done 2 years prior. So we're looking at it from a standpoint now. We did use a polish-resistant aggregate blended with a lower quality, which is a D aggregate in Kentucky. We blended that at 50-50. The other one in the other part of the state done 2 years prior was just D RAP with D aggregate, so a low-quality RAP with a low-quality aggregate. So we're trying to compare apples to apples to see what the friction values will bring. So being able to utilize this is, I think, very important for the state, and I'm hoping that other states will try to implement some of these and being able to possibly do not just single courses, let's look at doing double courses with RAP. Let's utilize those commodities that we have within our state. So the other thing, I want you to notice that the difference, this one right here that says August 24th, it's in red, that was the first project we did. Can anybody tell me the difference between the June 10th, the first day here, that was done with the RAP versus this one here? What do you see different in the picture? The weather was different. It was a little bit cooler. It was foggy. So we had a lot of moisture being expelled out of this material. What I found when we did this project, as you can see, it was a bright sunny day. It was very warm. Pavement temperatures were a lot warmer. I didn't see near as much water being expelled out of that material. The other thing that was interesting about this was Strasser provided the RAP for the first project. It had been processed the year before and just screened when we used it. So the project that was done in Kentucky where we used our RAP, it was processed the same year and then it was also rescreened in the same year. So I don't really know and haven't figured out why one project seemed to have a lot of excess moisture in it and not so much in the other one. Was it the climate? Was it the processing? We're still trying to figure that out. That's why we look at each other and we share these conversations so that we can all grow and learn from this. We're also still looking at, they have ran this route, they haven't got the information back because this guy collects all this data, then it comes back and it gets processed, it gets put in the spreadsheet and sent back out to know what these friction values are going to be. So I'm hoping these friction values are going to gain, and we're going to see a big significant difference by opening new faces to this high-quality aggregate and being able to utilize it in other ways. So now I'm going to talk about Cape seals. So we know we can do wrap chip seals, right? We know we can do wrap micro. Let's take it a step farther and let's put it in a combination treatment. Strasser has done this before, but the city of Lancaster did their wrap chip seal for them, and then they did the wrap micro over it. This year, they did a project. We did this, and you know pain points, right? When you talk to agencies, what their pain points are. So I went and talked to this agency, and these are over $1 million homes. They're like, oh, we cannot do a Cape seal. We will not do that. They won't tolerate the dust, the shed, all the things. I said, have you ever thought about doing wrap chip seal? Well, obviously, they didn't even know what wrap was. So I met with their trustees, met with them. I said, listen, you have zero dust because there's no dust in it. You have better retention because it's coated in binder already. So you're eliminating a lot of the problems that you're already talking about. So they was going to have to go to a mill and fill, or they had to do a Cape. So they trusted me. We did a wrap chip seal. 2 days later, we're microing over top of this. So we placed it June the 14th. This picture was taken September the 8th. So you can see it's performing very well. You don't see any bleeding. We don't have any issues. This agency is back to using Cape seals. They was going to take Cape seals completely out of their preservation treatment. Now they're back in business with doing that because they can't afford to do mill and fills. So this gave them an opportunity to use wrap and combination treatments. So let's think about, what other options we have out there. Think outside the box and be creative, because there's ways to use this material, and it's a commodity that we can use. And I wanted to share this picture right here. I was talking about Andy coming down and us doing wrap chip seals, so I just wanted to show you the difference. I wish I had taken a picture of when we did the wrap chip seal that Strasser did. This is actually State Forces right here. First time they'd ever chip seal in their life. And this is the wrap, and they ran out of wrap, so they finished the road using, just regular crushed limestone. So being able to see that a little bit, you can see that bleeding. This is the other thing that I really like about using wrap. You can see a little bit of bleeding right here in the joint because they did 2 separate passes, right? Do you think they didn't have that here? I bet they did. And you just can't see it. So this is my testament that using wrap is very beneficial to the agencies, because first off, if they had to do striping on this, you'd have to fog seal the limestone to see edge lines. With using wrap, you do not have to do that. So it's very aesthetically pleasing. So I'm a believer in pavement preservation. I'm a believer in using wrap, and I think it's a commodity we need to use in the future. So I'm going to play a short video here, and me and Mike are going to change places, and then we'll do questions at the end. Mike?
So this video was actually taken in City of Lancaster, which is the very first agency in Ohio that did this project. It was part of a research with Ohio University and ODOT in order to get this going. So they just screened the material, and essentially they got the size 57 aggregate that they used to bed pipe with. They got the chip seal aggregate, and they got the micro sand. Everything else that was larger, they just pushed off into another pile. So here you can see actually the wrap chip. They did this in-house with their own forces, and then we came in with our crew and actually put the micro down on top of it. You can see tons of commercial traffic, it's still in great shape, and because they're screening it themselves, they wanted it a little bit finer. Wish I would have brought the picture, I can set it directly and put it on the presentation, but it is very, very smooth because they went a little bit finer with the gradation. You gotta excuse the mess, so this crew was actually mostly office personnel, but one guy on the suite who was actually the president of our company, so it's not something we do actually every day. When customers call, you gotta get the work done, right? All right, so I'm not a great presenter, not nearly as good as Zach or Paris, so got to bear with me here. Already. Okay, so Rex called me and said, hey, will you come talk about fibers and micro? And my mind instantly went to a project that we did in 2019 that we got with Forda with to do. And like Paris was saying, you know, we have to listen to our residents. Dust for chip, micro. What's the most common complaint about micro? Anybody? It cracks. That's exactly right. It cracks. So we worked with Forda and their fibers to work on a solution to the cracking pavement. That was a softer binder micro. So we blended a softer pen liquid with your standard traditional micro liquid to get a softer material. I'm going to show you some of the testing here first in videos. So this is a test we did in the lab before we ever went out to the field. And basically what we did is we took these molds, glued the micro down, and did tension tests. You can see how rigid that micro is. It actually broke the glue before it bent the metal. Now this is the soft binder with the fibers added, and you can see how much more that pavement gives. We did several of these tests, and we actually have one that actually has a point in the middle of the metal because it's so soft that the metal bent before the micro gave out. We used to take these to shows like this, but the first thing everybody would do is pick it up and go. I can't make them all the time. But you can see, much, much softer, right? And what the fibers are allowing us to do is it's keeping the aggregate suspended, it's reducing and eliminating basically the plow damage and eliminating the rutting. So the fibers are really helping us get to someplace we've never been able to get to before. So this is a quick video of the road. You'll see the pre-existing conditions of the pavement. Pretty cracked up. A lot of top-down cracking here, no base failures, right? This is all top-down distresses. This is actually where the fibers go in. You can get that from Forda. It is hydraulically controlled, and I can get a printout every day. So if my DOT folks are in here and they want to know how much material we're using, we can get you that. The guy on top of the machine actually puts the fibers in, and the fibers are added to the mix. Forda's in here, I believe it's 0.2% of fibers per dry aggregate weight. This is about 6 months after the job was completed. Looks fantastic. Part of this program, we wanted to make sure we researched it, so we actually went out and crack mapped. We paid a third party to go out and crack map it for us. They did 100-foot sections, so this is the cracking beforehand. This is that same exact area 1 year later, and this is 2 years later. Once again, we didn't stop all the cracks. Zach usually says, what's your famous quote? If I can stop cracks, different tax bracket, that's right. So the whole goal here is to minimize and delay the reflective cracking. This is that road. Notice the barns in the back. 2019, this is before we did the project. 2021, notice the barns in the project. We do have a couple of those big working cracks coming back through. And then this is 2025. I actually missed the mark. I wasn't as close as what I should have been. You can definitely see there's some cracking coming back in this pavement, but it's significantly better than what it was. And our whole goal with using those fibers is, once again, to minimize and delay the reflective cracking and reduce the plow damage. This is an up-close picture. You can actually kind of see them that I took. These are the little fibers all throughout the mix. So you can see the dispersion. And actually, when you look at this pavement still today, it almost looks like it has diamonds in it because those fibers reflect the sun. So it kind of glistens in the sun. It's pretty cool. Any questions about this? Go ahead.
Yeah, the fiber, how long the fiber is?
The fibers are only about 1/4 inch long. And I was actually going to bring some samples, but it's a shameless plug for Forda. They actually have baggies at their booth, so go see them and you can check out their fibers.
Do you think it's because of the soft pen, it's the advantage of the cracking that comes through, or is it the fiber?
You couldn't do the soft pen without the fibers. Essentially, you're going to have significant running issues, and then also the aggregate would not stay suspended in the emulsion. It would actually sink to the bottom, and you'd have major issues. So the fiber is allowing you to combine those two.
Was this a wrap job too, or
No, this was not a wrap job. This was done in 2019, which several years before we started getting into wrap. Haven't checked the compatibility with that. Fordham may know. You guys know? Compatibility with the wrap and the fibers, it probably wouldn't make a difference.
I haven't seen that yet.
Yeah. Definitely not a lab guy. I'm kind of a jack of all trades, master of none, so. Last slide here. This is actually Min-Roads data that you can get online. So what they did is they took two different sections. The white is your standard control. It's a standard micro. And then the blue is a standard micro, but it actually has the fibers in it. And this was a great case study because, yes, we had great success with the soft binder fibers, but this is showing over time those fibers are really helping reduce and minimize the cracking. 37% less cracking by using the fibers. And once again, we see great success reducing plow damage as well. What was that? No, that is not soft base. That is standard micro. These are both standard micro in Emerald's, the study that they did. And I think that's really all I got. I just wanted to make sure that I showed this. Kentucky, 2 big projects this year. Ohio's doing a bunch of just standard, and it really doesn't raise the cost that much to add the fibers into the mix, and the results are well worth it. Questions? I know it's fast. Go ahead.
I don't know if it's a stupid question, but when you're using wrap and microfibricide and stuff like that, you're using an aggregate that's already been, I call it caramelized from the binder from the first time.
Yep.
How does that affect the absorption and binding and adhesion? Because I've noticed that that aggregate is not as sticky, you know what I
Yeah.
mean?
So-
That binder, is that affecting the quality of that?
So Rex actually did a great presentation out at the Midwest Pavement Preservation, and he asked the question, is it just black rock, or are you getting a benefit? With traditional hot mix asphalt, when you're mixing and making that hot mix, you're reheating the aggregate, so you're getting benefit from the liquid that's on the stone. In this process, it's ambient temperature. You are not gaining anything, you're not changing the polish or the numbers of that material itself. It's essentially a pre-coated stone, but you know, the fun fact, and I usually start when I talk about wrap, is what's the most recycled thing in the whole entire world? And you usually get steel, copper, gold, the list goes on, but it's actually wrap. So there's an abundance of this material. We have a sister company out in California, and they're actually running out of stone. The quarries out there are running out of stone. So everybody in the industry, it may seem funny around here, but this problem is gonna start creeping up on people eventually.
So like,
Yeah.
moisture content in the wrap versus like virgin material, you have a problem with that?
That just has to be checked, just like every other, your micro sand piles. But yeah.
We do in Phoenix, because there's a catch-22 there. You gotta get moisture in that wrap ahead of time because it won't take water like an aggregate does from the machine. But if you get moisture in it too early, you can't get it out of the dump truck.
Yep.
So, but when you, and we've had Jevy do some testing for us on the wrap, and you know, if the crew's having to run 12% water in the mix on the paver, it's not mixing. That water's just staying on top, it's not getting it, it's just causing an issue. So that is one thing with wrap is how do you get water into it without clogging up your equipment? And then if you don't get water into it, it doesn't do any good.
And it's definitely a learning process, right? That light show we showed you the video, they use 100% wrap, and they only screen their wrap. They don't have any issues with it reconglomerating at all. Now, when we crush it, we have the issue with it, and that's why we went to a 50-50 blend. So we're still very early in this, and we're still learning. And you know, I talk to agencies all the time, and well, we tried that, and we're never doing that again. And I always think about like Thomas Edison, the light bulb. Like if that dude tried one time, where would we be? You know, and the other analogy is like your iPhone, right? 20 years ago, we were carrying around bricks, Nextel bricks. Now you got a computer in your pocket. Like things are ever evolving and changing. So I encourage everyone, try it, and if you fail, try again until you succeed. Question?
I live in a township, or no, a city where you guys did wrap.
Yes.
Micro and wrap chip.
actually have pictures at the office where we did a traditional micro and a wrap micro. Yeah, it's been 5 or 6 years now, and wrap micro is still definitely darker, and we're hearing from agencies they use less salt and pre-treat because that material is holding the heat more and getting the snow to melt faster, quicker.
So Mike, about bleeding roads, do they bleed out faster using wrap or not?
It's really, it was kind of early on in the process when we were using 100% wrap that we were having the issues with. We did get some flushing on roads, but it was more because of, I think, our own failures of mix design, gradation, things like that we were having issues with. Once we kind of tweaked and fine-tuned that, that's where those issues have gone away 100%.
And then get run in, does it run in faster than conventional chip seal?
Yeah, we've actually ran into projects that an agency will call up and say, hey, I got a huge wrap pile. Okay, cool, let our lab guys come take a look at it. Lab guys quantify it and say it's good. We get out there to do the work and it sets up so fast you can barely get it out of the back of the box. So you really have to do your due diligence and make sure you check your wrap source, supply, work with your contractor, your agencies to make sure you're getting a good material. It's definitely important. Questions? Awesome. Yeah.
Do you find, and I understand that Harris is, when you're paying $125 a ton for rock, yes, wrap is cheaper. I'm not seeing a lot of places in the country where wrap is saving that much.
It really depends. There's places that they're giving away wrap in Central Ohio just because the trucking costs, they don't want to truck it back. They'll give it to you for free. There's other places you can get it for $7 to $10 a ton, and it depends on your processing. You know, if you're processing 10,000 tons, it's not a big deal, but if you're processing 200 tons, then yeah, it doesn't make sense. So.
The other thing I think about that too is just like Kentucky not having a polish resistant aggregate, if we get those new bases
Yep.
and being able to gain those values, that's gonna save a cost saving. But it's just being able to explore those things and thinking outside the box to see other uses for wrap.
Yeah, and a lot of these DOTs, you know, if you're speccing that kind of polish resistant or special aggregate, when they go to do a mill and fill, mill that stuff off, and you're keeping it right there in the right of way. You pay third party, or you even go in and process it yourself, and then we're basically supplying the emulsion and the manpower to do the work.
We could even have a contractor, process the wrap for you, and they just use maybe microsurfacing sand, and then you do the chip aggregate. So, I mean, there's different ways you can do that.
Absolutely.
That was one thing that I had learned from New Mexico. So collaboration is big. So don't be afraid to collaborate with some of these other either agencies or contractors or whoever you need to be able to grow the process within your own network.
Okay. Anything else? Thank you. Appreciate your time.